All right, yeah, that Mark's talk really set us up nicely for this talk, which is about carbon storage, downwood and understory plant species diversity after thinning. So I'd also like to acknowledge my co-authors who also set me up nicely to talk about this topic. So in this talk, I'll give you some background on the carbon cycle and managing forests for carbon and climate mitigation, and discuss briefly some of the trade-offs between managing for carbon and other important objectives like diversity. And I'll go over some results from the density management study looking at total above ground carbon, the distribution of carbon among major pools, the effects of topographic position, and looking at how that varies from the effects on plant species richness and the relationships between carbon and plant species richness within forests. So just briefly, again, I don't want to spend too much time on this because Mark just covered it nicely, an overview of the carbon cycle. Forests sequester carbon from the atmosphere via photosynthesis, so they're taking up carbon and lose carbon by respiration and biomass removal during timber harvesting. So storage is, again, the balance between sequestration and losses. And there's a lot of interest recently in managing forests for carbon mitigation. And the main recommendations are to maintain or increase forest area and increase carbon storage within forests by maintaining dense forests and extending rotations. However, we also have to manage for biodiversity, and we recognize that there's an important role of disturbance in maintaining diversity within forests. And as a result of the unique recent history of the cutover, the landscape is dominated by young, dense, even-age stands. So people have been using thinning as a tool to accelerate the development of structural heterogeneity in old-growth structures and functions within these stands. So while thinning may decrease carbon storage, it enhances biodiversity. So there may be a trade-off between managing forests for carbon and diversity. Here we examine the effects of alternative density management practices on carbon storage and sequestration and analyze the trade-offs and synergies between management for carbon versus biodiversity. And while the understory vegetation comprises a very small pool of carbon in the forest relative to the overstory, which stores over 200 times the amount of carbon as the understory contains most of the plant species, 20 times as many plants. So we'll be using the understory as an indicator of diversity in this study. And we're also using the experimental structure of the density management study, which has a broad suite of residual density treatments that most of you are likely familiar with. And we'll be quantifying the effects of these treatments on some of the major carbon pools in forests, including the above ground live vegetation, excluding the understory, as well as coarse down wood, and breaking that down into small pieces versus large, and looking at the distribution among decay classes and snags and stumps. We do not have data on fine litter and detritus or below ground biomass or soil carbon. So these graphs are similar to Klaus's, where as we move to the right along the horizontal axis, we are increasing the intensity of thinning. And this shows that thinning beyond a high density retention decreased carbon storage. So that's thinning beyond 300 trees per hectare. However, this doesn't account for post-harvest off-site storage and emissions due to harvesting and processing. And I want to apologize that most of my units are metric, but 1 megagram or metric ton is equivalent to about 1.1 tons in English units. So looking at different carbon pools, we see that the majority of carbon is stored in the live overstory. So that's these blue bars here, followed by large coarse woody debris, which comprises about 25% to 30%, as much as the live overstory. So it's still an important pool. Within the live overstory, most of the carbon is stored in bollwood. So removing the bolls during harvesting, although it helps to leave the barks and branches, is removing a significant carbon pool. Within the coarse woody debris, most of the carbon that we have is in later stages of decay, suggesting kind of a legacy. It's a legacy of the original clear cut. So we have deficits in early stages of decay, so we want to think about recruiting some more fresh wood into this pool in the future. And this distribution across the landscape is really heterogeneous. So on this map we have, you can see there's a lot of topographic variability, and the sizes of the dots indicates the amount of carbon in coarse down wood. So it's really variable, and that's part of what would occur naturally. So there's no need to create a very homogeneous distribution of coarse woody debris over space. However, in contrast to the effects of thinning on carbon, we saw that thinning increased plant species richness. And again, this is repeating what Klaus mentioned earlier, that it didn't vary among the different thinning treatments. And these graphs show that overstory, well, we have plant species richness on the vertical axis and carbon on the horizontal. And the relationships between carbon and species richness varied among sites. But for the most part, there was a negative relationship between plant species richness and carbon. So as we thin and reduce our carbon storage, we're increasing plant species richness at this very local scale. And over time, looking at variation between 11 versus 6 years after harvesting, the carbon increment, so the difference between year 11 and year 6, did not vary among treatments. So although we did see this decline with increased thinning intensity, that relationship was not statistically significant, suggesting that the faster growth in the lower residual densities does partly compensate for some of the biomass removed at this whole ecosystem scale. And looking at the same thing, changes in species richness, we see that within the control and high retention treatments, richness did not vary significantly between years 11 and year 6, while over time richness declined in the moderate and variable density treatments, so as thinning intensity increased. This increase in richness was more short-lived as the early cereal species become competitively excluded by the shrubs. So in summary, thinning to less than or equal to 200 trees per hectare, or 80 trees per acre, reduces above ground carbon storage. Differences among treatments were related to reductions in the live overstory pool primarily. The distribution of carbon from large coarse downwood was not related to treatments or topographic position, and plant species richness was related to increased with thinning and decreased with total above ground carbon. So there does appear to be a trade-off. And looking at differences between year 11 and year 6 post-treatment, carbon increment decreased with residual density, although that relationship was not statistically significant. And declines in species richness occurred in moderate and variable density treatments. So while there appears to be a trade-off between managing for carbon and biodiversity, so the question is can we have our cake and eat it too? And to manage for both, it looks like we need to vary densities across stands and across the landscape in order to maintain both carbon storage and biodiversity within forests. And there might be an important temporal component to investigate as well, as over the long term, these effects may feed back on each other. So biological diversity may enhance carbon storage over time and result in more adaptable and resilient forest ecosystems. And likewise, carbon storage may function to maintain diversity as well. So that's it.
Now, those were really interesting data, and I like that perspective. And I wonder if you'd be willing to speculate what happens when you get stands by the time they're 50 years old, if they've been thinned. You have trees with large crowns, and you have trees that are very responsive to thinning. And I'd raise the question, I think there is generally understood, once you reach about 160 square feet of basal area per acre, there's a wide range of densities up to mortality where the productivity per hectare per year is almost a constant as a function, irrespective of density. And if you were to have a thinning program, they would say thin at 210 square feet down to 160 or 170 and let it work back up again. You'd have really a flat line of total primary production, and you'd be exporting some carbon and building up the storage capacity of the stand. Now, maybe you could expand on the feasibility of that idea in ways that would tie into the density management study.
Yeah, so I think that you know, thinning can enhance the ability of the forest to store and sequester carbon, we can also do things like maintain and recruit dead wood to enhance carbon storage. So I guess I'm not quite sure what exactly you're getting at.
Maybe I can add a comment on that. Having a little more experience than Julia in this force, she's been here now 11 months in the Pacific Northwest.
8.
8. So I want to point out, when we thin, we have a few different effects that thinning has. It lowers the density, and so therefore provides the resources, but it's also a physical disturbance in the forest. And that again creates that, environment that allows germination and invasion of new species on that. So in that sense, if you had the repeated disturbances on a smaller scale, like Mike suggests on that may provide some kind of a balance on that. So again, as kind of pointed out, you can kind of shoot for the middle ground where you have both, or you separate those two goals and say, I have certain sites that for one reason or another are better suited for storing carbon, and we emphasize that a little bit more. On the other hand, other sites that for various reasons we stress the biodiversity aspects, we manage for those. I think those are the decisions that the landowners have to think of. Obviously, they can't have both on that. You can get close if you hit the middle ground by going at higher density, and then you have to come in repeatedly and thin, which has its own set of costs and issues associated with that. Any other questions? Thank you, Julie.